Okay, so this is a good fit under new findings. IRENA, the International Renewable Energy Agency, just released this report on World Energy Transitions Outlook 2022, how to get to 1.5 degree C pathway in terms of energies, options, technologies, barriers, policies, access, investment, and so on. There is good news, of course. If you look at global investment in energy transition technologies from 2010 onwards, you can see here the mix going mostly from renewable energies to add EVs, electrified transport, electrified heat, energy storage is being added. Hydrogen is there somewhere, you cannot see it yet. Carbon capture and sequestration is there, but you cannot see it yet. And fortunately, energy efficiency is also being added. Investments have gone up, but obviously the question is, are we on track for the 1.5 degree C target by the end of this century with the 66-67% probability, and what are the kind of goals we need to meet by 2030 and 2050 to get there by 2100, especially in the energy systems. That's the main goal of this report, which is 348 pages long with enormous amount of detailed information, countrywide information, specific energy details, specific policy baskets and so on, which I'm not going to go into because I'm just going to reduce it into a 10, 15, 20 minute podcast here. Okay, but you should definitely look it up, which is available for free online. So with that good news and background, we can look at the summary figure kind of saying reducing emissions by 2050 through 6 technology avenues. Here we have renewables. So the total needed to get there is 36.9 gigatons of CO2. Of course, theoretically we should look at CO2 equivalent, because as we know, if we don't include other greenhouse gases, this target could be missed, so we have to be careful about that as well. 25% of it from energy efficiency, electrification of transport, heating, and various other things is going to give us 20% reduction. Hydrogen is going to add 10% in reductions. Fossil fuel based CO2 capture and storage 6%. Are we there yet in terms of technologies for these? Not quite, but this is by 2050, and you obviously would hope that we will be there. Renewable energy based CO2 removals through, let's say, bioenergy, carbon capture and sequestration is 14%. There are lots of issues there as well in terms of conflicts with food security, food prices for the poor, land use, sustainability of biofuels, and so on and so forth. Okay, there is a long caption here that obviously I'm not reading. So let's look at the 2050 roadmap and then come down to 2030 to see what are the most urgent ones now and what are the targets for 2050. So roadmap to 2050, tracking progress of key energy system components to achieve the 1.5 degree C target. It splits into renewables, energy efficiency, electrification, and hydrogen, and carbon capture, sequestration, and bioenergy with carbon capture and sequestration. I won't read all the details, but it provides you an idea of where we are in each item and where we need to be and whether we are on track or off track. So you should look through those more carefully. But electrification with renewables, for example, we are at 26%, and by 2050 we need to be at 90%, and we are kind of on the middle of the road here. Addition of renewable energy, for example, 264 gigawatts per year. We need to hit 836 gigawatts per year not bad in terms of the trajectory we are on. So similarly, annual solar PV additions, annual wind energy additions, investments in renewable energy generation, and direct renewables in end uses has things like share of renewables in final energy consumption, where we are and where we need to be, and we are off track on this one. And we are also off track on geothermal consumption, off track on district heat generation buildings, where the centralized systems can reduce energy use and of course emissions. In terms of energy efficiency, energy intensity improvement rate is okay, but investment needs for energy efficiency, we are off track. So electrification, we are okay on share of direct electricity in final energy consumption, but passenger electric cars on the road, we are off track where we, in terms of the trajectory we are on. We are at 7 million per year here now. By 2050 we need to be at 147 million per year. There are details. If you have lots of EVs and the energy source is not clean, and the grid is not able to support clean recharge and so on, then obviously there are issues there as well. Investment needs for charging infrastructure of EVs, again we are off track only at $2 billion per year. We need to ramp up to $131 billion per year by 2050. Hydrogen, basically off track on all items in terms of clean hydrogen production, investment needs for clean hydrogen infrastructure, and clean hydrogen consumption industry as well. So is that bad news? Not necessarily. Knowing that we are off track can help us get back on track, or at least look at how to get back on track and track the barriers that are there to get back on track. Carbon capture sequestration, we are off track. Obviously we are only at 0.04 gigaton CO2 captured per year. We need to ramp up to 3.4 gigaton CO2 captured per year by 2050. Scalable technologies as such do not exist, so this is going to be a challenge. BECCS, again we are off track with 0.001 gigaton CO2 captured per year. We need to ramp up to 5 gigaton CO2 captured per year by 2050. Moving on to emissions reductions over 2018 to 2030. Here are the emissions, and the legend is in the next slide. We need to rapidly phase out coal power, and expansion of renewable power needs to keep up as well, so that we can bring down the emissions and even go negative emissions on many things, like renewable energy share in electricity generation must increase by 65% by 2030. Share of direct electricity in total final energy consumption must rise from 21% to 30%. Deployment of energy efficiency measures must increase 2.5 times. Direct renewables in the end-use sectors must grow from 12% in 2019 to 19% by 2030. So 2030 is right around the corner. We are already in the second quarter of 2022, so that's not good in terms of the trajectories we need to stay on. So the legends here: process and non-energy, natural gas, oil and coal, so correspond to these. Sorry for splitting it, but just do the back and forth yourself. Energy conservation and efficiency, renewables, so power and direct uses, electrification of end uses direct, and hydrogen and its derivatives, carbon capture and sequestration in industry, BECCS and other carbon removal measures. So we can see many of these have to serve as negative emission technologies, or net removal of carbon from the system. Obviously we need some key performance indicators for achieving the 1.5 degree target by 2100. So by 2050, electricity generation with renewables, share of renewable energy, average investment in energy intensity improvement, share of direct electricity, clean hydrogen, and total CO2 captured. So the report tracks these things in separate chapters with enormous details, but keep again that the question is always where we are now and where we need to be and whether we are on target. Often on target, off track doesn't on track, off track doesn't necessarily tell you whether technology is ready right now or it needs to be ready to get back on track. So that's a kind of a prickly detail that, for example, carbon capture and sequestration, we do not really have scalable technology right now, but we need to get there. Total investment by technological avenue for present energy scenarios and the 1.5 degree C scenarios over 21 to 2030 need us to go from 35 trillion to 57 trillion, so up 2.2 trillion per year in these various categories that we already looked at. Okay, again, power grids, energy flexibility, carbon removal, CCS and BECCS, hydrogen and its derivative, electrification and its use, energy efficiency is a big chunk here that needs investment. Electrification in end uses is somewhere here. The colors are not very obvious, or I'm colorblind. Renewables, renewable for power generation and direct uses and district heat. Fossil fuel, we need to phase them out with proper investments, removal of subsidies and so on. Fossil fuel and nuclear power, fossil fuel energy here. Okay, so what does that give in terms of investment? If we have a proper holistic policy framework to go with these investments for the energy transition in terms of energy, economy, society and planet, with deployment policies, integration policies, enabling policies for the transition, structural change and just transition policies, holistic global policy framework, all working together, then we can expect certain good things. For example, energy sector jobs in India in 2019 and under the present energy scenario and the 1.5 degree C scenario, considering this requires $22 trillion more or $2.2 trillion more investment per year. The number of jobs per million, here is where we were in 2019 in terms of conventional energy dominating employment, other transition related sectors adding a fair bit and renewable energy being a small bit. Present energy scenarios will increase those and reduce the conventional energy or maybe keep it the same. But 1.5 degree scenario will increase renewable energy jobs tremendously. Other transition related sectors will be a huge increase, and there will be a slight drop in conventional energy. So the investments do have a payoff. Of course, the question is where the money will come from. Electricity and clean cooking access rates also have to go up from 2009 to 2019 and where we would be in 2030 estimates, and what the gap would be to accomplish 100% access rates in terms of the electricity gap and the clean cooking gas gap. So these have to be met as well. This fits under the SDG goal 7 on affordable and clean energy goals to be met by 2030 as well. So that's always good to keep in mind in terms of quantity, quality and access to energy, so that the energy transition doesn't just worry about 1.5 degree C target as a all-encompassing goal, but does it in a just and equitable way as well. Okay, so that's a very quick run through of a report that is very long, but I hope I captured the most salient points, and the details are there in the report that you can follow up. Okay.